Welcome to the 13th podcast on taxes and subsidies. In the previous podcast, we have seen that both a technology standard and a performance standard may achieve the socially optimal levels of abatement, although a technology standard does usually not achieve the socially optimal level of output. In this podcast, we are interested in answering the following question. Is it possible to internalize the environmental externalities, either by putting a price on environmentally harmful activities, like a tax on pollution, or by encouraging environmentally friendly activities through a subsidy on emission reductions? We will first address the case of a tax. We can think of the example of the producer polluting the river and the fisherman who is affected by the release of chemicals into the river. So remember, the chemical producer had a marginal cost of production, here in green. And the fisherman incurred damages because pollution affected her catch and thus her profits. The higher the quantity of chemical released, the lower the fisherman's profits. So by taking into account this damage, it leads to a social marginal cost represented in blue here. And the marginal benefit of the firm is equal to P star, which is the equilibrium price on the market. So in the absence of regulation, the firm would produce Q star units of the chemical, which stems from the equality between marginal cost and marginal benefits. But if the damage to the fisherman is taken into account, we equalize the social marginal cost this time with the marginal benefits, and we get Q soc, the socially optimal quantity of chemical produced. And Q soc is smaller than Q star. Now, say we impose a tax T on each unit of the chemical. The tax then shifts the marginal cost of the producer upward. And so with the tax, the new marginal cost of the producer is MC plus T, and we represent it in red here. Therefore, the marginal cost of production is now higher for each unit of chemical produced. So what does the firm produce in this case? The equilibrium with the tax is found at the intersection of the marginal benefit curve and the marginal cost plus tax curve. This gives the quantity QT produced after introducing the tax, which is lower than without the tax. It was Q star before. Of course, since the quantity of chemical decreases, it also decreases the damage to the fisherman. But what is the optimal level of the tax now? What's the right tax that has to be imposed on the firm so that we reach the socially efficient level of production Q soc? Well, that's exactly the difference between the social marginal cost curve and the private marginal cost curve. And this difference represents the marginal damage to the fisherman at the socially optimal level of Q. So T opt must be equal to the marginal damage at the socially optimal quantity of chemical produced. So T opt rises the marginal cost of the producer to MC plus T opt. And when the firm takes the tax into account in her profit maximization, the equilibrium is found at the intersection between the marginal cost corrected for the optimal tax, the red curve, and the marginal benefit curve. This leads to a production of Q soc units of the chemical, which is the socially optimal level of production. The tax is called the Pigouvian tax, and it is named after the French economist Arthur Cecil Pigou. Now, let's do this a bit more formally. The regulator imposes a tax on the production of the chemical. So the firm takes this tax into account in her profit maximization. The tax increases the firm's costs by T times EI of QI and AI. The first order conditions are as follows. With respect to QI, we get that the price is equal to the marginal cost of production plus the tax times the marginal emission from production. With respect to AI, we have that minus the marginal cost of abatement is equal to the tax times the emission from an additional unit of abatement. We can interpret these conditions The first condition says that the firm produces up to the level where the marginal benefit of production is equal to the marginal cost of production plus the tax on emissions times the increase of emissions due to an additional unit of QI. The second condition says that the firm will abate up to the level where the marginal cost of abatement is equal to the marginal benefits of abatement. So the tax times the decrease in emissions due to an additional unit of abatement. So the right-hand side of this condition is actually the marginal benefit of abatement, because if you abate more, it means that you produce less emissions, so you have less taxes to pay. Now let's compare the case of the tax with the social optimal. Can we achieve the socially optimal levels of both production and abatement with the tax? We have on the right the conditions under which the socially optimal level of production and abatement are reached, and on the left, the case of a tax. By comparing the two sides of the table, we clearly see that the socially optimal level of production is reached as long as the tax is equal to the marginal damage. And we can see that it also holds for the socially optimal level of abatement. So the first order conditions coincide if we set T, the tax, equal to d prime of E, the marginal damage. The tax must be equal to the marginal damage. That's the rule. However, there are some difficulties in setting the tax correctly, because in order to set the tax at its Pigouvian level, policymakers need to know the marginal damage, so the shape of the damage function, the slope in particular. They need to know the marginal cost, so the shape of the cost function as well, of production and abatement, as otherwise they would not know what the optimal levels of output and abatement are. So this means that the regulator needs pretty high levels of information. And in practice, damages of pollution might vary across space and or time. For example, climate change does not affect each country evenly. Also, emissions cannot always be monitored directly. CO2 is invisible, for example, or only monitored at high costs. Therefore, as an alternative, shall inputs to production or output be taxed instead when pollution is hard to monitor? Whether inputs to production or output shall be taxed instead of emissions directly depends on their correlation with emissions. If the correlation is perfect, then a tax on input or output is equivalent to a tax on emissions. Think of the following example: fossil fuels and CO2. We know that 1 liter of gasoline yields 2.3 kilograms of CO2 emissions. That is a chemical constant, so we cannot change this relation. So that means we can actually tax gasoline when it is sold at the pump, because we know how many units of emissions that will yield. But if the correlation is imperfect, then it is better to tax the activity that releases the pollution. Then it would be better to tax production or consumption. Think, for example, of scrubbers. Some firms may install scrubbers, and if we tax output, we tax both firms which install scrubbers and firms which didn't. So that's not what we want. We want to tax those which really pollute. In this sense, this would be better to tax not output but pollution itself. Now, let's turn our attention to a subsidy on emission reduction, in other words, on abatement. We are going to compare it to the case of a tax. In this diagram, emissions are depicted on the horizontal axis and marginal costs and benefits on the vertical axis. We have the social marginal cost of emissions, which is rising with emissions. This is representative of the damages. And the marginal benefit of emissions, or equivalently from production, which decreases with emissions. At some point, marginal benefit is even equal to 0. That means that increasing even more emissions or production does not yield any benefit to the firm from a certain point. In the absence of regulation, the level of emissions would be set to the level at which the marginal benefit from production is equal to the marginal cost of emissions. But with no regulation, the marginal cost of emissions is zero. There is no abatement. So the level of emissions with no regulation is here, where the marginal benefit of emissions is zero, or equivalently, where the marginal benefit curve intersects with the horizontal axis. Now, what's the socially optimal amount of emissions? We saw that it is where the marginal benefits and the social marginal cost intersect. So we have to set the Pigouvian tax, T-opt, at the level equal to the marginal damage from emissions. And from this tax, the government raises these revenues, the red area which is equal to T-opt times EI-SOC. Now let's compare the tax case with the subsidy case. A tax is set on emissions, but by contrast, a subsidy is set on abatement, which is just the opposite of emissions as shown on the diagram. So by considering abatement, we need to interpret the two curves differently. The social marginal cost of emissions is equivalently the social marginal benefits of abatement, because the more you abate, the more you reduce emissions, and the more you get benefits. And the marginal benefit of emissions or production is the marginal cost of abatement, because if you abate more, you have lower emissions, which means that you produce less, which is a cost to you. Again, in the absence of regulation, the firm would not abate any emission, so there would be zero abatement. What happens if we set a subsidy S-opt on abatement? Then the firm would set the social marginal benefit of abatement equal to the marginal cost of abatement. The subsidy is clearly a marginal benefit for the firm from abating pollution. So with a subsidy, we would also achieve the socially optimal amount of emissions or abatement, ESOC, as would do a tax. And the government would have to pay the green area to subsidize firm, which is the area between the laissez-faire scenario with no abatement and the socially optimal level of abatement. Even though we can achieve the same amount of emissions with a tax on emissions or a subsidy on abatements, there are a few caveats with the subsidy. A subsidy reduces average costs, whereas a tax increases them. That implies that under a subsidy, some firms that have a very inefficient technology might stay in the industry, whereas under a tax, they would leave the market. Also, the subsidy might encourage entry of new firms because a subsidy is a benefit for the firm. Pollution as well might not go down as much as under a tax. And importantly, the government can use the funds for a subsidy for other purposes, whereas the tax raises revenues which can be used to fund public goods, for example. Subsidies can be widely observed in practice because there is less political opposition to a subsidy than to a tax. A subsidy avoids putting the industry at a competitive disadvantage compared to firms facing less or no regulation, for example, in other countries. And in some cases, firms might not have the funds to reduce pollution, in which case subsidy to abatement is a good idea. So, to sum up, if set at their Pigouvian level, taxes can successfully internalize environmental externalities, which means that it achieves Pareto-efficient levels of output and abatement. However, the information requirements are pretty high, and subsidies to abatement can do a similar job, but it might be easier to implement from a political point of view. The problem is that they are also more costly to the taxpayer, the regulator.